In section 8.5, we're going to hit the last of our heavy hitter by hand techniques for integration, and this method is called the method of partial fractions. And it's best illustrated with an example. It won't mean much to you unless you see what's happening. So let's suppose we wanted to integrate this function right here, this rational expression. What are some strategies we might employ? Well, okay, there's always decomposing the fraction. We could split it up. So decompose. You could also use long division. This one will not use long division because the degree of the numerator is less than the degree of the denominator, but long division is an option. And we will actually do some long division in this section because it does come back, sorry to say. So we would break it up into 3x over x squared minus x minus 6 dx plus 11 over x squared minus x minus 6. And this has done nothing, nothing at all. Boo, yuck, right? It's still a terrible, terrible integral. Both of these are awful. You can't use U substitution easily. You could maybe complete a square, but it wouldn't do you much good, and it's a mess. Okay, speaking of completing the square, let's try that. That's a method. Not one of your favorites, but we could do it. All right, so we could see that the denominator is a trinomial it's a quadratic trinomial. So we can try completing the square. Completing the square is a technique for quadratics. Trinomial quadratics at that. So we could say it's 3x over, and then say x squared minus x, and then what you have to do is take b, which is that number right there, so negative 1 over 2. So it's b over 2, and you square it. So negative 1/2 squared, which would be 1/4. So then you would add 1/4, then take away 1/4, and then you have your minus 6 still sitting there, which would be dx, which would be the integral of 3x over x minus 1/2 squared minus, negative 24 over 4 minus 1 more over 4, which makes negative 25 over 4. Even worse, right? This is awful, right? There's no easy U substitution. There's no integration by parts, right? Because this isn't a product rule. It's just a mess. Yuck, yuck, yuck. Terrible, terrible, terrible. All right, so that leads us to our third option, which is we could factor the denominator. Which may not seem promising, but it is. So we have 3x plus 11 over, and then it's x minus 3, x plus 2. And this is promising. There's more to it, though. This leads to the method of partial fractions. This is the way we're going to go. All right, before we even get there, though, let's take a moment and look at what partial fractions are. So what if I told you that that integrand, 3x plus 11 over x squared minus x minus 6, is equal to 4 over x minus 3 minus 1 over x plus 2? Wouldn't that make the integration easier? And the answer is, oh yeah, it would. I mean, it would definitely make the integration easier, for sure, because it would be the integral of 3x plus 11. I'll give it a big yes, by the way. Would be the integral, dx, I lost my dx, integral 4 over x minus 3 dx minus the integral of 1 over x plus 2 dx. And both of those are actually very easy to do, right? This would be 4 natural log of the absolute value of x minus 3 minus the natural log of the absolute value of x plus 2. Okay, so if we could break up our integrand into two fractions, and you'll notice that those two fractions have the denominators of the factors of our original denominator, which is very key to all of this. That's what I'm saying when it leads to the method of partial fractions, right? It's going to lead to this. But the process of taking this rational expression and decomposing it into simpler rational expressions, that's called partial fraction decomposition. So when we do this, that's what it's called, right? Many integrals involving rational expressions can be simplified greatly if we can do partial fraction decomposition of the integrand. The trouble is that doing partial fraction decomposition is a bit tricky. It involves quite a bit of algebra. So that will be what we're going to do for the next couple pages, is learning how to get from here to here. But once you are here, you can see that the integration is actually not difficult at all, right? So the integrals are simple. The trouble is getting to that point. So the integrals are simple, but finding the fractions is difficult. I shouldn't say it's difficult. It's gonna be tedious. But the integrals, the integration will be very easy once we're able to do it.